So in today's lesson, we'd like to review our zero and negative exponents properties. Recall that to divide two numbers with the same base, we subtract their exponents. A to the m divided by a to the n is a to the m minus n. Take a look at some examples. 2 to the 7th divided by 2 squared, we simply subtract the exponents of 7 minus 2, and that is 2 to the 5th. X to the 4th divided by x cubed, 4 minus 3, x to the 1st, or simply x. Well, let's look at what happens when we have the quotient of same numbers. Find the quotient of each of the following. 15 divided by 15, negative 67 divided by negative 67, 2 to the 5th divided by 2 to the 5th, 96 to the 3rd divided by 96 to the 3rd. Notice that in each of these four cases, the quotient is 1. Well, now let's look at this thing called the zero power property. And if we use the quotient properties of exponents, 18 to the 6th divided by 18 to the 6th, 4 squared divided by 4 squared, 25 to the 7th, you can see my problems. We'd have to subtract the exponents in each case. So 18 to the 6th, 6 minus 6 would be 18 to the 0. 2 minus 2, 4 to the 0. 25 to the 0, and 121 to the 0. But, as we learned on the last slide, any number divided by itself is 1. That should say 1 there, not 0. That leads us to the zero power property. And it's simply this. Any number or any letter raised to the zero exponent is always 1. Next, let's talk about something known as the negative power property. So again, let's review the quotient property of exponents. X to the 6th divided by x to the 8th, y to the 5th divided by y to the 12th, t squared divided by t to the 5th. So if we wrote these out, we'd be looking at x to the 6th, y to the 5th, t squared, x to the 8th on bottom. Notice there's 8 factors of x here, 12 factors of y, 5 factors of t. By subtracting these, we get the following. 6 minus 8, this would be x to the negative 2. The middle one would be y to the negative 7. And the last would be t to the negative 3. But if we cross out, because remember we can cross out factors that are the same in the numerator and denominator, look what happens. Cross out a pair of x factors, another pair of x factors. And as we keep going, notice that what we have left, we have just 2 factors of x that happen to be in the denominator. So this will become 1 over x squared. Remember, every multiplication problem has the hidden ninja factor of 1. It's just when we cross off all the factors on top, that power has to show up. Take a look at the second example. Here's a pair of y's, a second pair of y's, third pair of y's. So we cross off 5 pairs of y's. Notice that we have at the bottom 7 factors of y left over, nothing at the top, so the hidden ninja 1 has to show, and we get 1 over y to the 7th. Finally, for our last example, we cross off the t's, another pair of t's. So we have 3 factors of t left in the denominator. The 1 has to show, and it becomes 1 over t cubed. So if we put these two ideas together, because they're both equivalent, t to the negative 3rd by subtracting the exponents is the same as 1 over t to the 3rd. And we get the negative power property. A base with a negative exponent can be rewritten with a positive exponent as its multiplicative inverse. Multiplicative inverse is just a fancy way of saying reciprocal. So take a look at our examples on this slide. 5 to the negative 2nd. Well, we flip it with a positive exponent, 1 over 5 squared. 1 over x to the negative 3, well, since it's at the bottom, we'd flip it back to the top, and we get x cubed. Take a look at these final examples today. Evaluate the exponential expression. Write your fractions in simplest form. 3 to the negative 4th and 4 to the negative 2nd. So the first thing we have to do is we have to flip them to make the exponents positive, and then we use our calculators and we work out. 3 to the 4th power is 81, 4 to the 2nd power, 16. Take a look at our final examples. Rewrite the expression with positive exponents. 3 different problems here. 1 over 2x to the negative 5th, 8 over m to the negative 2nd, and x to the 4th, y to the negative 7th. Anything with a negative exponent flips. If it's in the denominator, it flips up. So our first answer would be x to the 5th squared. Notice the 2 doesn't flip because 2 is not to a negative power. Same thing here in example 2. The m to the negative 2nd, the m has to flip to the numerator, and it becomes a positive exponent when we flip it. The last example, the x can stay up top because it's not to a negative. The y has to go to the denominator because it's a negative power. That is our lesson on zero and negative exponents.